Welcome to our channel Electronics on Wheel and thank you for your support. So today we are creating one more video where our subscriber has requested that how to read the wiring diagram. Can you please make one video on that? So wiring diagram generally taken care by the technician on the dealer network and the service networks where they read the wiring diagram and try to diagnose those particular faults. So we will take today some of the wiring diagrams from the different OEMs. So especially we will take the horn diagram, wiring diagram that will tell about the horn structure, how it is wired, and we will try to figure out how to diagnose that. So in today's video we will learn how to read the wiring diagram. So whenever you find a fault or issue in car, so we just jump to start the working on the particular component or particular problem. But our first approach should be you need to check your wiring diagram, because you might be having different wiring diagram for different car, right? So suppose you have worked on the Maruti Suzuki on 2 years back, and now you have the same problem with a different brand of a car, like suppose Honda. So you cannot say that the same problem will be solved in the Honda as well in the same way which you have done in the Maruti Suzuki, because they might be using different concept or different approach. So you need to have your wiring diagram in your hand before working on any type of problem or any type of diagnosis you are doing. So even you are an experienced guy, still you require wiring diagram. So as I told you, the reason behind this, the technology is changing every day and very fast, so you cannot follow the same process which you have followed 2 years back or 3 years back. So to diagnose effectively you need the wiring diagram in your hand. So let's get started. So before going to wiring diagram, so I have taken one of the example that when you get the wiring diagram, so this is the first page that index you have. So here you will have all the description of the functions or system you have, and then you will be having the wiring diagram in the subsequent sheets. So first we will see, I have taken one example of Tesla Model X. So I'll give you some overview here. So what does it mean? Sorry, let me take one moment. So yeah, so the first page would be giving the description of your functions. Sure, why it's not working? So okay, let me show this way, not a problem. So this particular thing would be the first page would be describing about the functions, that what are the functions you have in this. So these are the description of your functions, and it gives the page numbers, where are they, these functions are located. So suppose if I am going to find out some like driver inverter, so I should go to directly on the page number 20, so that I can find out directly the wiring diagram of that particular function. So this is the description of the function or wiring diagram which is given on a first page. Then you have the power distribution and grounding strategy. So I many times told you that power distribution and grounding strategy is the pillar to find out or diagnose in any problem. So if your fuse itself is not working, then you can't do anything, right? So you are not getting the power, and you cannot diagnose that particular thing. So you should have to have the look of the power distribution, that is your fuse box, that suppose how many fuse box you are having. So you can see here that we have the front prefuse, then permanent rails permanents, that in we have the in cabin 3, and then we have two in front, and one is in a front prefuse. And then grounding also, if you see that we have in a pillar, then firewall, and then front and rear. So this is how grounding and power fuse distribution has been distributed, you can see here. So then there are some of the abbreviation has been written that you are going to use in the wiring diagram. So if suppose LF is written, then you have to understand that this is left front. If MF is written, then you have to understand right front. So these are the some abbreviation you have to go through before working any wiring diagram. So it would be better to understand if you go through with the abbreviation. Then we have the harness designator. So as I told you many times, we have many different wiring harness, and different OEM follow different structure of the wiring harness. So if you see here, so they are using the B for the right body harness, then C for the central console, then D for the left door harness, K for the headliners. So these are the different harness designator, and if something is written on the wire, then you have to understand, okay, we are talking about the LR door harness. Then wire color designators, if you see somewhere on a wire that BK is written, that means that black, then BN brown, then GY gray, YE yellow. So these color codes, I feel that most of the OEM follow the same, but there is a chances of using the different as well. I cannot rule out this possibility as well. So you have to see whenever you are going to this. Then wire type designator. So if you see here, they have used four types of wire: FLRY A, FLRY B, and you can see that this is 105 degrees centigrade rated for both the thing, but this is for the regular standards and this is for the bunch conductors. So you have to understand. I will not go in detail of why we are using FLRYA, FLRYB. Many times in previous videos, we have discussed all these things. Then MSIV and XR15. So XR thin wall 150 degrees centigrade, and this is used for the cross link and highly flexible cable. So mostly if you go with the power cables, you will get this type of coding on them. Then we see some of the journal notes. So you can see that the relay or switches are in active state. Wherever you will get, that would be de-energized. Then splices may split across the pages. So what does it mean? Like, two, you have the like 56 circuits, so one splice might be split into 3 to 4 sheet as well. Then fourth, notice some connectors are split across the multiple pages. So similarly, like splice we have talked, so same thing is that. Wire sizes are specified in square. So most of the OEM use this thing only, squares. Only American AWG use like 20 and 20 23 like that. They don't use squares. American gauge AWG, but most of the, either it is American company or the European company, so most of the companies follow this one because it is acceptable uh, all across the OEMs. So wire specification, you can see what type of wire specification that they are using: 60 volt, then what is the temperature range, then which particular wire is standard they are using, 672. Then you have the terminal plating as well, which plating you are using, whether it is gold terminal or silver terminal. Then inline connector gender is specified by the male and female. As you know, one side it would be male and other side it would be female. So for male we can say tab or pin terminals, or for female we call it receptacle and socket terminals. So these are the interchangeable terminology which you can use for male and female. I hope you understand the basic things. Now we will see in this how they are using here. So suppose this type of wire circuit you get, right? And now you have to understand this circuit. What does it mean? So the first thing is harness. So I told you A means, if A is written, so A means what is the meaning of this? So here you don't have any A terminal. Here is just giving the example. So if I'm not wrong, So A is not here. So suppose here if it is written like B, then it means that the right body harness. We will see that example. Then device option code. This is the device option code. Then this is the connector. This is shows about the bus termination. Then first digit in this connector shows the connector, and second will tell about the pin numbers. You can see here. Then as I told you, the plating also, it will tell about the plating. Then inline connector, male side, it would be written like male contact and female contact. So it is not visible here, but I'll just tell you. So suppose X207M, so M shows male side, and X207F, then it shows the female side. This is the meaning of here. And here you can see that there are circuit numbers, then circuit segment here, then wire color code, wire size here you can see, then wire designation, wire type designation you can also see, then vehicle option code, then length of the wire also here. In Tesla's wiring diagram, they also mention the wiring diagram, sorry, length of the wire in that. Then harness assembly wires belongs to. So without further delay, we just go to the one of the circuit diagram, and we will try to find out how to diagnose those particular circuits. So I have taken very simple circuit, that is the home circuit, which is very much similar in most of the car companies. As you can see that I have covered the total four cars company. That first one is the Jaguar I-Pace, then second is the Tesla Model X. Then we have the wiring diagram of Mahindra as well, and wiring diagram of Toyota. But function is same, that is our uh, horn. So I will show you from the beginning that how you have to read the wiring diagram of different company. But nomenclature which I have told you in the first page, it might be very based on the company to company. Okay. So as we have seen right now, the wiring specification, this particular table and general specification for this, I will go first Tesla Model X, and then I will come to this Jaguar Pace. So let me show here. So this is my wire, right? So as I told you, these are the some of the codings which has been written on this. So you can see this is the wire color code, this is the wire CSA, this is the wire type. Then here some coding also written here you can see. And that coding, whatever coding here they have mentioned, that is the same thing which we have explained on the first page. But most of the time you are worried about when you are diagnosing the any circuit, then you are worried about the color and the connector specification. So I will show you the connector specification or connector view also, so that you will get the clear picture of that. So this is how you have to read your wiring diagram. And if you see here that this is the 218, what does it mean? That this is the connector, and this is the 18th pin of that connector. You can see X002, X003, this is our nothing but, if you see here, so we have seen that X001 is the connector and pin number 1, right? So this is how you have to see your wiring diagram. Now coming to the Jaguar Pace, Jaguar I Pace diagram, they have given somewhat more structured way from the beginning. So as I told you many times, so the first thing we will start with the 12-volt battery. Okay. So you know that there are different type of wire supply, right? So direct power supply from the battery, and then second type of supply is ignition supply, right? It means that component is powered only when your ignition switch is on. Then you have the type of power supply like accessory power supply. So when you put your ignition switch in the accessory, then you will get your power. But when you see this particular horn circuit, then you will come to know this is a battery power supplied circuit. I will show you how and why it is saying like a battery power supply circuit. So let's start with here. So this is my 12-volt battery, you can see here. Then module battery monitoring system. So this is nothing but so now the technology is very advanced. So we have the battery current sensor and battery monitoring system, so where your battery will be monitored whether it is charging or not charging. Second thing, how much it has charged and when it has to be stopped. So there are many different requirement on the battery startup as well. So that's why this battery monitoring system is also installed. But we have to take care of the main thing, which is like the battery negative. If you see, that is written BK, this is the color, and this is the wire cross section. If you see the 50, and then 385 is the length of the wire, and then it is going to battery earth, which is going to be your chassis or BIW. Then you have the holder fuse, that is 450 amps. So as I told you, this particular fuse is a part of your primary fuses, right? Because it is a like mega fuses, it is mega fuses. Then 50 square mm of wire is coming, and 295 is the length. Then this is the color RD, red. Then you come to the junction box battery, where you have the again one fuse, that is 250. This is also part of primary fuse only. uh, it is comes under the mega fuse, this comes under the secondary fuse. We will come on this. Then we are moving to the junction box front right. So these are the secondary fuse boxes. So here you can see that this is junction box front right, and it is our 35 square mm. Then it is going through this, and it is going to your 15 amps of fuse. This is our secondary fuse. Then it is going sorry, this is a part of this only junction fuse box front. Then you have the relay, this is the relay. This relay is going one part, that is the controlling part, it is going to the horn. And then it is going to the second wire is going to your grounding. And here also you can see the how much wire CSA has been taken, 1 square mm here. And this is our coil side. And coil side, if you see, it is controlled by the BCM assembly, that is our BCM, body control module. And you can see output horn control, and this is the input. So input is coming from the module steering wheel. So in your steering wheel, you will be the horn, having the horn switch. From horn switch, so how it will perform, I will tell you this thing. So first, this is your horn switch in your vehicle, right? So once you press your horn switch, the signal will goes to BCM, body control, input will come. Then it will go to your horn relay. This horn relay will be having the coil. Once the current will flow through the coil, then magnetic field will generate, and this magnetic field will, what it will do, it will pull this contact and make the contact, and then your horn will blow. This is the process of horn horn working, right? So I hope you understand how this wiring diagram of Jaguar I-Pace is giving the clear information how you have to read the wiring diagram for the Jaguar I-Pace. But if you see the other wiring diagram of other OEM, this horn is very basic, simple function. It would be same for the other Tesla model also. If you see here, this is your body control module, BC front, right? This is this. See, the representation might be different for the different, but the concept will remains. They have written here horn relay, but actually from front body controller, how it is going, it is going here, here, then you have the this side, then you have the horn coil. So actually here also you are controlling from the BCM this coil, and this coil, once the current will flow, then magnetic flux will generated, and this contact will make the contact. Then you have the fuse, then you have the here, the only difference is you have the horn right and horn left, but in the case of Jaguar you have only two horn only at one position. Here you have the horn right and horn left, which is controlling. But if you see, by this looking at this horn structure or horn wiring diagram, you can directly tell that both the horn will blow once, because simultaneously, means, okay. So once this current will flow here, then magnetic flux will generate, then this will make the connect. And if you see the horn left and horn right is connected here with the splice, and then it will give the current to both of the horns, horn left and horn right, and they are grounded here. So if you see the ground also, the ground left is given for the separately, and ground right uh, is giving for the separate. So ground RF rail 1 and ground LF rail 1. So left hand side is grounded on left hand side ground, and right hand horn is grounded on right hand side. So this is, but the concept is same. If you see here also and here also, the concept of horn is remains same. Then moving to the our Mahindra. So in Mahindra also, if you see, it is more more detailed way, where it has been written what is the contact numbering of the relay as well, what is the battery rating, what is the wire CSA, then fusing. However, you are getting this information there, but terminal numbering you are not getting for the relay there. Here you will be having, these are the your inline connectors, junction box, joint connectors, then you have the ground. So I'll show you from the beginning here. So ground on steering wheel, so this is your horn button, that is the part of your steering wheel which you press. Then it will go to the rotor connector, then it will be having the clock spring, and then from clock spring it will go to your relay. Okay, so relay will be, I have already told you why we are using the relay here. So you are controlling, so suppose I'm here, they have used 15 amps fuse. So in contact side there is a possibility that 10 amps of current would be flowing from this. Okay, so suppose if you are directly controlling this horn without giving this relay, then the first thing what will be having, you have to develop a high current switch, which is costly. Second thing, even you develop that high current switch, there is a possibility of arcing, because you are continuously switching on and off that particular horn. So it is a possibility that it will burn out. So that's why we use the relay, where we are controlling this high current circuit, this one, the load side, with the minimum current, that is, I have already told, that comes under the milliamps. And this is a register based relay. So in some of the video I will tell you why we are using here register, sometimes we use the diode as well. But moving to our topic, so you can see here, this is the terminal 86 and 85. So these numbering are very much defined by our DIN standards, which I have told you earlier also. So 85 and 86, 85 on the this side and 86 in this side, and 30 is a power side, and 87 on this side. All right. So here also the same thing would be happening, that once you will push this button, what will happen then, this current will flow in this. Once the current will flow, what will happen, that magnetic field will generate. This magnetic field, what it will do, it will you know close this circuit here, then your horn will blow. And how to read and how to diagnose, we will just try to understand now. So first you have to understand that how this particular circuit is working. Then we will see the diagram of Toyota. So it is also same, but here we will try to explain some more thing. So here you have the battery. So sometimes you might have seen that some OEM write here battery, some OEM write here ignition, some OEM might be writing as an accessory. So what does it mean? So there are three types of supply, as I told you. So it is directly coming from the battery. Even you are just putting your key, then this particular horn will blow. Okay, you have no need to rotate your ignition switch. But suppose if I write here the ignition, so what does it mean? Till the time you put your vehicle in the ignition on mode, till then your vehicle, your horn will not blow. That is the meaning of this. So what does it mean? That it means the component is powered only when ignition is on. If it is ignition on is written, if battery is written, it means that all time the power will be supplied to the horn. This is the fuse, that is 10 amps of fuse we are using here. And this is our splice. So from the splice we are taking one side the coil side and other side is the contact side. So contact side, if you so see that this is our horn assembly and this is going to our switch. So now we will try to understand that what are the steps, how to diagnose it. Okay, so we will diagnose everything from the voltmeter itself. Sorry, voltmeter itself. Okay, so you will be having some voltmeter where you will be having one positive code and then you having the negative code, right? So one thing you have to understand, whether you are working in electric vehicle or you are working in a ICE vehicle, that is our internal combustion vehicle, this 12 volt will remain same throughout your system, your wiring diagram, your schematics, whatever you say. Because even if you are using the electric vehicle, right, so still you are using your auxiliary secondary battery, which is our 12 volt battery, and for that particular 12 volt battery is powering your whole circuit. Okay, so whatever you are using for the horn or some other system, it is you are taking from 12 volt, right? So my question is here, if you, the first thing in diagnosis, the first step number one, what you have to do, first you check the fuse. Check the fuse first thing is this. So how to check the fuse? Are you going to take out that fuse and you are wanting want to see? No, you don't not do all these things. You do not take out that fuse and you have to see. What you have to do, let me just erase this thing. You will be having your voltmeter, right? This is my plus, this is minus. So here what you have to do, you have to just take your positive and you have to just ground this, okay, somewhere on the chassis, and just check out how much voltage it is coming. So it should come 12 volt. If it is coming 12 volt, what does it mean? That your fuse is okay. Till here, till this point I take is at a point. So till here you are good, right? Then if you are good, then not a problem. But if you find that 0 volt or some different, right? So what does it mean? If it is 0 volt, it means that there is a possibility of your fuse is blown. You just check out your fuse, take out the fuse from the fuse box and just check whether the element inside the fuse is blown or it is still okay. Most probably it would be blown. If it is, you are getting the 0. We have covered till here this a point, all right? So till here our function or our wire is okay, our fuse is okay, our wire is okay if you are getting 12 volt, right? Now coming to the coil side, right, of the relay. On 86, you just try to check how much voltage is coming on this side. So as I told you, if you are working on this, right, and it is grounded here, right, it is grounded here, it is controlled by the ground on this side, this switch, right? So what does it mean? Suppose as I told you that there might be two cases. When switch is off, when switch is off, then here it should get, you should get 12 volt. When switch is off, then your coil is okay. Till here you should, till a part, I take this B here, this point is B, then I take the C point, then D point. These are the, IC, that interconnector, then E point I take, then here I take the F, and then I take here G. Okay, so first case, when your switch is off, then how much voltage you are getting? If your switch is off, so because I told you that if your switch is off, then your current is not flowing here, right? If your current is not flowing, then your voltage is constant throughout your vehicle, right? So there is no voltage drop when there is no current. So you should get 12 volt on this point also, 12 volt on this point also, 12 volt point on this point also, and 12 volt on this point as well. Till here, till point F, you should get 12 volt. If you are getting 12 volt, then you are all fine. If it is not 12 volt, if you are getting here 0 volt, it means that your coil has gone, because you are not getting here, right? The voltage is uh, is something different, or you might be having the open circuit here. Suppose you have the open circuit here on the coil side. So what does it mean? So till here point A, I'm getting 12 volt, then this coil is open here. It, what does it mean? It means that on point C you will not be having anything, right? Till here only you will be having the 12 volt. So you should understand, okay, my relay has gone, I have to change my relay. That type of understanding you have to develop when you are diagnosing your issue in the vehicle. You can do everything from the voltmeter. If you are good with your basic concept, then you can do everything from the voltmeter. But if you are not good on your basic concept, then you have to see your diagnostic error codes. You have to purchase your scanners also coming around, I think 1 lakh, 2 lakhs, 670,000. But if you are good in your basics with your voltmeter, then you can do wonders, and you can find easily those particular issues. Then this is the condition of off, right? If second condition is your switch is on, your switch is on, what does it mean? That it is grounded, right? It is grounded. It is grounded means that here what would be the voltage? That would be 0 volt. Let me just erase everything. So now we are taking the second case, when your horn switch is on, right? When your horn switch is on, what does it mean? That it is 0 volt, right? Here, then here it will be 0 volt only. Here also it should be 0 volt. It should be 0 volt. Here also it should be 0 volt. Why it should be 0 volt? Because when you have the 12 volt from here, right, then uh, what volt needs? Voltage needs the path to pass, right? If you do not have the path, then it will remain same. But if you have the path, so it was coming 12 volt here, then it's seen that there is a path to and flow the current, and all the voltage will go to the ground. Okay, you got my point? If you got this basic concept, then you can really understand the diagnosis process. Okay, just try to understand this thing. One more time, I just tell you what does it mean. So till here I am getting 12 volt. When it was off, then I was not having any path to pass. So till here this was 12 volt. But when I did my push button horn button closed, what happened? My all the ground, all the voltage gone into the ground. Okay, this also depends on many things. Okay, there are two types of switches, normally open and normally closed. We will see this this particular thing as well. Right now I am talking about the normally open switch. Okay, here if it is closed only, then horn will be blown. So I am talking about normally open switches right now. So if it is closed, my switch is closed here, then my current will flow like this, and my voltage, all voltage will be gone to the ground. That would be 0 volt. So it would should be 0 volt. All the points it should be 0 volt because I have grounded everything. If you got this side, if you see this side, left side, I'm good. I'm good on the left side. Now I can check the contact side as well in the same way. When you are having your normally open, normally closed situation, then you can check everything. The volt contact side, whether contact is intact or not, right? Whether my horn is intact or not, whether you are getting the 12 volt till here or not. When you are switch when your contact is closed, whether you are getting the 12 volt or not here. If you are getting, then good. If you are getting here 0 volt on this ground, then it is good. If you are getting something different, then it is a problem, or your ground is not proper. So this is how you have to diagnose your things. You have to check, left hand side also, the everything you have to check. Right hand side also, the first point you have to check your fuse, whether your fuse is working fine or not. Most of the time 50% of your issue will be solved by this itself. Then you should check your grounding is intact, or you have no need to check the grounded by going on this point. You can check just by voltmeter whether my voltage on this point is coming right or not when I'm switching on. I hope you understand the concept. If you understand this concept, I'm going to create one series for all the wiring diagrams, whether it is a starting system, charging system, or many parking headlamps, many wiring diagrams. And you can just comment in the comment box which wiring diagram of which OEM you want to have in the next time. I will take one particular wiring diagram, or mostly all the wiring diagram with one by one, step by step, so that here I have not shown the connector view. That plays also very important part. When you have these type of connectors, right, here you have the connectors. So which pin it is, like 8 pin, you have no need to go to other pins, you have to go the particular pin when you are checking the voltage from voltmeter. So you just comment in the comment box if you want this series. So I will make more wiring diagram videos on that, and you can comment on the which OEM wiring diagram you want to understand. Thank you for your time. Please like, subscribe and comment if you think that it is adding some value to your knowledge. Please support by that. Thank you.